Problem solving with two sets. Okay, some key knowledge here is that the cardinal number of A union B equals the cardinal number of A plus the cardinal number of B minus the cardinal number of A intersection B. So what does that mean? It's easier to understand if you look at the Venn diagram. So if we wanted to know what is the cardinal number of A union B, we would add the 7, the 5 and the 10 together to get 22. However, if we wanted to know what the cardinal number of A union B was by focusing on how many elements are in A, which is 12, and the amount of elements that are in B, which is 15, we would have to acknowledge the fact that the 5 elements in the intersection belong to both A and B. Okay, so if I find the union by adding the 12 from A together with the 15 from B, I'm going to have to take away one of the 5s to acknowledge the fact that it's been counted twice. So that's where we get the 12 plus 15 minus 5 to make sure we don't count the 5 twice equals 22. Okay. Now this is a very useful tool for problem solving. You actually end up with 3 ways to find the cardinal number of A union B. So first of all, you can do it the regular way, just count the cardinal number of A union B. Or now you can say it's the cardinal number of A plus the cardinal number of B, take away the cardinal number of the intersection, so we don't count it twice. Or in fact, you could say it's the cardinal number of the universal set, take away any elements that are in the complement of A union B, any elements that aren't in A union B. Now, if you look at it from all of these different angles, this can help you with some questions. So here we have a question, find x. We're told that the full number of elements in A is 14, the full number of elements in B is 20. We're told there's 4 on the outside that don't belong to A or B. We're told that the full amount in the whole universal set is 35, and that there's x amount of elements in the intersection, and we have to find that x. Now, first thing is, if we focus on A union B, we could actually find it, A union B, by looking at the cardinal number of U, take away the complement of A union B, so the 4 that aren't in there. So A union B could be calculated as 35 minus 4, which is 31. Okay, now an alternative way of looking for A union B would be to find the cardinal number of A plus the cardinal number of B minus the cardinal number of the intersection. So that would work out as 14 plus the 20 from B minus the x in the intersection. So adding your 14 and 20, we've 34 minus x. Now what we've done is found 2 different ways to find A union B. So both of those answers should equal each other. So putting 1 equal to 2 and solving, we have 31 equals 34 minus x. Add x to both sides and subtract 31 from both sides. So x equals 34 minus 31. So x equals 3. Okay. So that brings us on to questions where we can be asked to maximize the cardinal number of U. So what we've just learned is that the cardinal number of A union B equals the cardinal number of A plus the cardinal number of B minus the cardinal number of A intersection B. So because of that, therefore, the cardinal number of A union B is at a maximum when the cardinal number of A intersection B equals 0. So in layman's terms, what that means is that the amount of elements in A union B is at its most if there's no overlap between A and B, if there's no intersection. So here we have a question, for what value of x is the cardinal number of U at a maximum, and what is that maximum? So here we have x is the number of elements in the intersection. A has 31 elements in it, B has 45 elements in it, and there are 10 elements not in A union B. So for what value of x is the cardinal number of U at a maximum? So it's when x equals 0. Okay? And then what that means is that the total number of elements, if x equals 0, will be all of the elements in A and all of the elements in B. You can see by them not overlapping, you get the most from both sets. So the biggest amount of elements, or the most amount of elements that you can have, will be the 31 plus the 45 plus the 10 on the outside equals 86. Then we can be asked, how do we minimize the cardinal number of U? So going on what we know, that the cardinal number of A union B equals the cardinal number of A plus the cardinal number of B minus the cardinal number of A intersection B, it means that therefore the cardinal number of A union B is at a minimum when A is a subset of B or B is a subset of A. So in other words, A union B is at its smallest if A gobbles up all of B or B gobbles up all of A. Okay? And in these questions then, it's going to be the bigger one that will gobble up all of the little one. Okay? So look at this question. For what value of x is the cardinal number of U at a minimum, and what is that minimum? So it's the same question. Now here, B has 45 elements, so it can gobble up all of A, which is 31 elements. A has 31, so it's too small to gobble up all of B, which is 45. So what we'll go with is that B will take in all of A into itself, okay? And that means then that A intersection B will be all of those 31 elements, okay? So all 31 will go into B and none will be left on the outside in A only. Okay, so U is at its minimum when x equals the cardinal number of A. Okay, that might be easier to look at if we look at it like subsets. So here's B, and it has gobbled up all of A into it. So those 31 elements become the intersection between A and B. And you can see what has happened. Because it has gobbled up all of A, that means we're only now counting the 45 elements of B and the 10 elements that are outside of B, which leaves the universal set at a minimum. 45 plus 10 equals 55.